To all, today's agenda is to discuss our two lessons, which are quite easy and it's all practical dependent. The first one is natural language processing, and the second one is our web scraping. Let's see how much we can cover in these two topics. Okay, so let's get started with our today's goal. Natural language processing with sklearn or scikit-learn package. First of all, let's try to understand that what is this process of natural language processing. For the time being, I'm going to discuss here all these points here, as you can see, and let's take some of our examples here. Please, participants, don't share the mail ID in all panelists or all. Make sure that you change it to host and presenter before you share your mail so that it will be not made public. Quickly do that so that we can discuss the rest of the things. Those who haven't received, please check your spam email before you send your confirmations. Please check your spam. Maybe you might have received the mail and it might be there in the spam. Okay, so I'm gonna discuss the next part here with yeah. I'm gonna discuss here about our next part, which is natural language processing. The idea of natural language processing is about using the unsupervised learning data set, especially we are talking about not unsupervised, the unstructured data set. We are talking about unstructured data set. This is a processing of an text type of data, text data types, analysis. So it is an automated way to understand and analyze the natural human languages, which we are mostly talking about here in this case, that we have got the various natural human languages and they will be mostly in text. So what is the idea behind here is that we have to look for processing of these data sets, processing of this natural languages through the help of our various packages, various libraries which are available to us. One of them could be one of the major library that support the text analysis, where you can actually extract the text or extract the information from the text data, and on top of that you can apply some machine learning algorithms like naive Bayes. So the idea here is to target the text data This can be done by both the things. The sklearn package is also there, and on the other side we'll be having natural language processing library as well. You can do this analysis by the help of either, sorry, not NLP, NLTK. NLTK is the library name, Natural Language Toolkit, and the other one is sklearn. So you can use any one of these libraries of your own choice to perform the analysis over the text data. Perform the analysis over the text data, as you can see here in this case. So what we are trying to do here is we are trying to take the data from the various languages, and these will be all your natural languages, or you can call it as human languages. But these human languages are understandable by a human being. In order to translate this for machines, we need something in between in order to extract the information, and that's where these libraries will fit in themselves. It is done by either a sklearn package, or it can be done by NLTK package. Both are supportive. Obviously, to an extent, NLTK is much more supportive. The reason is NLTK is dedicated library for extracting for preparation of the data, for targeting the textual data here. Okay, and sklearn this is a general general package which help us in all the different in all your different analysis part as well. So that's how the things work here with the help of all these points, as you see. This is our lesson number 9, I guess. So let's try to discuss this. That how does we can do it. Natural language processing, it is also referred to as field of computer science or AI to extract the linguistic information from the underlying data. Linguistic informations related to the language, target here the languages here. So what we'll do in this case is we'll target the language, and we'll target to extract the information from these various languages. So extracting the linguistic information. Why natural language processing? There are lots of data which are available, like for example tweets are there, right? Somebody tweet on Twitter, though it is not much popular and not common and popular as other platforms, but this has been used. Anything happens across the globe and you wanted to put your views there, you will definitely, if you are, and you are friendly on Twitter, then definitely you will put your views there. Okay. This Twitter data is about text, is having text data here, right? All these informations that you see are in text. Now using this text, what you can do is you can perform the sentiment analysis. What is the meaning of sentiment analysis? You do sentiment analysis here. What is the meaning of sentiment analysis? You particularly target the word words which are used there, the text, and you try to analyze it in terms of if it is a negative sentence or if it is a positive sentence or if it is a neutral sentence. Okay? You take a positive sentiment is there, negative is there, or you can have also the neutral one. All right. Next is identifying the various languages, applying the quantitative analysis. That's where also the text data could be used. Remember, this is a quantitative analysis. For qualitative analysis, we have already taken the help of the other machine learning algorithms. But when it comes to quantitative analysis, we have to go through a process of first data preparation. In this case, the data cannot be prepared without the help of NLP. Like you are having another example, another real world example we can take spam email, right? Now in spam emails, if you wanted to do the classification of this, all you have is text. Again, you have just text, and this text data is also called as your qualitative. Sorry. This must be a qualitative analysis. You target the text, and this must be converted into some numbers. This must be converted to some numbers, and then on these numbers, you can analyze some algorithms. Without you convert them into numbers, these algorithms will not work. You cannot take a text data directly and you can fit them into any model. That won't work. So in order to go through this process of converting this spam emails into numbers form or numerical form, this is done by your NLP, natural language processing. So that these are some of the things where natural language processing are used. And here are certain examples like handling ambiguities, handling the spams or ham mails, then extracting the text information from the data by analyzing lots of data here. Okay. NLP can achieve full automation by using modern software libraries, packages, modules. Like you can create a pipeline here, and this pipeline, if it is connected to a live source, if it is connected to a certain live source, what could happen is that this live source straightforward can be connected to your pipeline, and here in the pipeline you will be having the sklearn library, for example, which will be doing certain type of let's say it is converting them into the machine learning models, or it is converting them into certain sentiment analysis, classification analysis. Whatever the thing you are doing, this can be made an automated process. Sentiment analysis, then you can also have spam, ham, classification, etc. So that's why natural language processing do play an important role. Some of the terminologies that we have to always be aware about as if you wanted to work with an NLP part. So first part is tokenization. First part is tokenization. Tokenization is related to splitting the words or phrases into the small text. Okay, you have the sentence. You have the sentence. This sentence will be converted into words. Similarly, paragraphs are there. Okay, let's say you are reading a book. If you read a book, you will have you have to go through by reading a paragraph. This paragraph will first chunk itself into sentences and then further you will chunk them into words. So in this case, what you do is you split the words, you do chunking. Take the entire paragraph, convert them into smaller sentences, okay, and then convert these sentences into the words. This is your first part. Next is stemming. Next is stemming. Stemming is particularly used for converting. So there are words here, there are items and phrases here. These words and phrases needs to be converted into their root word. Like stemming is a process of converting things like suppose going is there. Going, went, born. These all three words that you see will be treated as three different words until unless you don't apply stemming to it. What stemming will do is it will convert these all three words into a root word. What will be the root word for this? Root word is go. Root word is go. Okay, you can call it as root word, which is called as go. So that's how the things work here. Next is TF-IDF. TF-IDF stands for term frequency and inverse document frequency or inverse term frequency. So term frequency, sorry, IDF is there, inverse document frequency. So we are very much interested in knowing the frequency of words in a certain document, and then we are also interested in if we are having multiple such documents. So we'll be interested in knowing that what is the frequency of these words in those various documents. Document here could be your different text file or different paragraphs. Okay, so that's what this will be there. For the time being, just try to understand only the basic idea. This is where we are trying to find the frequency of words in each sentences. In your sentence by using the natural language processing part. Okay, next. The next thing that we have to take next thing that we have to take here will be related to semantic analysis. This is basically where where we compare words, phrases, and items in a set of document to extract the meaning from it. So semantic analysis. Next is disambiguation, where it determines the meaning and sense of the word, like context versus intent. Then next is topic models, where we discover the topics in collection of documents. Word boundaries, where it determines where one word ends and other word begins. So word boundaries are generally represented by punctuations. It is done by the punctuations here, like dot, comma, semicolon, etc. Yeah, I'll discuss everything, don't worry. When we'll do the practical part, we will discuss all these things. Okay. Now moving further here. Now moving further, let's take some. Let's talk about them. Next part, NLP approach to the text data that you see here. Okay, so let us get started with certain examples here, and then we will try to particularly implement this onto certain examples. I think this is more of a this is more of your actual analysis here. You can see some of the examples are available, bag of words, etc., and then certain NLP part. So let's try to do it, and we will also try to take the example of naive Bayes in order to perform certain classification here. But in order to reach there, we need to go through various other processes as well. We need to extract down and understand how exactly the NLP works, and that's where these particular part will be helpful. These NLP terminologies are there. So let's try to discuss that how does we can perform these different process where we learn about the various discussions over what is tokenization, what is stemming, then what is your TF-IDF, what is lexicon normalization, what are the different part of a speech tagging part is there, etc. All these things we can only do it on the practicals, and there only it will make more sense to us. Okay, so let's talk about this. Let us talk about this particular part in depth. Okay, for this we need to go ahead with our packages. So let's start with our localhost. Start a new Jupyter notebook. Everybody, begin your new Jupyter notebook here. And in order to perform the cleanliness part, we have to ensure that we take our target data and we try to eliminate all these unnecessary parts from the data set, and then we will do some tokenization part, etc. So let's try to study about this. So let's take the data set and let's try to perform these. So first of all, we can get started by taking a paragraph, and the first process is tokenization. The first part is tokenization. Tokenization is process of is process of breaking down a paragraph into smaller chunks of sentence and words. Sentence and word. I'm sending it on the chat window. This is also important. So please write down in this case the text part as well. You can name this as NLP basic. You can name it as NLP basics. NLP basic. So the first part is about tokenization here. Let us take first. Let us take here first the data here. Let us take here the data first. This is all about. Just a second. So straight away using the TF-IDF part. Oh. Okay, anyway, first let's take the sentences here. First, let's take the sentence. So I'm just sending you the sentence. This is a just general sentence I have taken from Wikipedia. I'm just sending you the sentence here in the chat. So I think it has not come up here. The entire words of sentences is a bit large. So I'm sending you in two parts. I'm sending you it in two parts. First, I will send you this one paragraph. First paragraph I'm sending you. This is your first sentence, and then this is my second sentence. Please ensure that you copy paste in such a way that they all should be presented in this way. Otherwise, you will get an error. Error will be that paragraph not found, etc. Okay, sentence created, everybody. Everybody has taken the, yes, what paragraph is created or not? Please do it fast. Participants, did you created the paragraph? Everybody has created the paragraph. Okay. So I think we let's try to study both the packages here. One will be your NLP package, sorry, NLTK package, and the second we can take the help of the sklearn package as well. So then only I think it will be easy for you to understand this. Okay, so let's take the packages first. This is our paragraph, and let's import the package. Everybody write import NLTK. Okay, NLTK you will import, you will see no error. And what you will do next is you will write here NLTK dot popular. Sorry, NLTK dot download, not popular, NLTK dot download. And you will write here popular. You will write here popular and you can simply import it. So these are all my packages which got downloaded. I'm sending you this in the chat. First, all of you must read a paragraph. You can take any paragraph here. It is not that you have to only take the paragraph that I have written. You can just take any paragraph. I'll be resending it for those who have just joined. Please ensure that you take all this part so that our analysis should look or appear same. In place of this text paragraph, you can have anything here. You can have a file full of text like, and here are your sentences. And here are your sentences. Now import the NLTK part. Import your NLTK and write NLTK.download popular. Popular will download all the popular packages that will be required by you. If you will not perform this, you will not get, your packages are not complete. This is not like other libraries. NLTK, all libraries contains more than 3 gigabytes of the memory. It will take more than 3 gigabytes. But what is the benefit that we get here is that you can download the important packages whichever is required by you. This will take some time. Meanwhile, you all see how I am doing the sentence tokenization part first. That I'll just move this part, I'll just scroll it down. First is sentence tokenization. First one is a sentence tokenization. Let us import the package from NLTK dot tokenize import sent underscore tokenize. Our paragraph is already been taken at the top. Let us convert this paragraph into a smaller chunk of sentences. Let us save the result into a tokenized text which will be given by sentence underscore tokenize, and you pass here paragraph. You pass here the paragraph. Then we take here tokenized text, and we'll be getting here the sentence tokenization. So after you have imported the packages, here are your NLTK tokenize and convert the paragraphs into the sentences. Wherever the full stops will be there, after that you will see that a comma is found. This is your first sentence. This is your second sentence. Full stop means that new sentence begin. So there are multiple sentences here that you can easily find here. This is the information that I have taken it from the Wikipedia for my previous batches, and that's how it appears. This is how your sentence tokenization works. Sentence tokenization is the first part here. We have converted the sentences into we have converted the paragraphs into sentences. Now from sentences, we will be splitting them into words. Phrases. Phrases. This is used to particularly target for a certain word. You can call it as multiple word here. You'll have this word expression, and using these multiple word expressions, we will be converting them into tokens. Like for example, in a sentence, you know that a certain words will appear. Okay, so you can try to group them and prepare them as a single sentence. Okay, so that is phrases. Then similarly, you can try to do the similar thing with the items. If you know that your sentences include items, so that could be also used. For the time being, I'm going to do the general. You have to wait until this popular begins, popular downloads. Okay, this will also depend upon your internet speed. Once your popular is done, then only you will able to see the output for these parts. Okay. Now after we have got the sentences, and the sentences are tokenized here, so let me send you this part, tokenize and tokenize text. Okay, so everybody copy it and hopefully are getting this type of result. Did you all got this output? Did you all got this output here? Please drop yes in the chat. This is a super simple part. I mean, you can all easily do it, and this is one of the easiest topic. Two is word tokenizer. Word tokenizer. Second part, word tokenizer. So instead of having the sentence tokenizer from nltk.tokenize, you have to replace the sentence tokenizer by word tokenizer. Okay. Now let's take our tokenized text. Replace the tokenized text with tokenized words. Replace the tokenized sentences or text by tokenized words. And take your word tokenize. And here is my all the data or all the values here. Okay. So that's one phase here. You can see that it has got converted into smaller words by using word tokenize. We have got the words ready. We have got the words ready. Got here my tokenization. After sentence tokenization, you have to do the word tokenization. After sentence tokenization, once we have got our tokenized words, let's focus on eliminating some of the unwanted elements from it. You can easily see when you see the tokenized words, you will see that even comma is considered as a new word. Commas are also considered as a word, which is totally wrong. There could be a possibility that might be you'll be having some question marks, etc., and they will be also considered as a word. So how to get rid of these useless things in order to prepare the text data? Sentence tokenization is chunking your sentences, paragraphs into sentence. That's the meaning of this. If you wanted to convert them into words, then either you can pass this as well. Yes, instead of paragraph, we will be using you can use a particular file as well, like a book, a textbook, you can use it. In place of this, you can use a text file as well. And then you have to implement and walk through this same process. Okay. Sentence tokenization is also there, word tokenization is there. Majorly, we have to discuss about the word tokenization as that is our that could be used for various process. So I'm gonna take the words further, and sentences are of no use for us as of now. But it doesn't mean that sentences are useless always. In this case, I am not gonna use, but maybe in some sentiment analysis where you don't wanted to like get rid of this sentences, you have to target only the sentences, and whatever the process I'll be doing here, this will be applied or implemented to the sentence rather than text. So same thing you can implement to the paragraph, same thing you can implement to text, words, etc. NLP tokenization and removing punctuations by using a regular expression. Regular expressions. From NLTK.tokenize, import regular expression tokenizer. Let's take here tokenize. Tokenizer equals to regular expression tokenizer. Now in this case, I need to target here all my words. So I'll just consider here word plus, which will target only the words. Next is my new words, which will given by tokenizer dot tokenize, and pass here my entire paragraph. Again, you can see that in this case I am passing all the paragraphs, but this time what you are seeing is we are again gonna get the words. So this is also doing the same thing as like your word tokenize. The difference is that this time we are tokenizing the words by using regular expressions. Like in this case, you can see that you will not find those unwanted question marks or all these parts. Rather than just displaying it like this, let's put them around print function. So you can see here, all these are your new words that has been created. All these are your part of tokens, as you can observe. In this case, we have considered the words part and the unwanted elements are gone. You can see that unwanted elements are gone from here. So once we have got all the chunk of new words, let's try to go through the frequency distributions through the plot, a certain plot. Fourth part I wanted to discuss here is frequency distribution. Frequency distribution. This we can do it with the help of again NLTK library. NLTK.probability import frequency distribution. Let's pick here fdist given by frequency distribution and pass here the new words. Backslash W is for ensuring that we'll only consider the words part and all those unwanted values like those symbols that we get at, exclamatory mark, ampersand, star, question mark, these are all will be not considered here. I'll just show you here. This is part of regular expressions. This is not related to just a dedicated thing which is used by NLP, but it is used wherever you see text data. Okay, I have used here backslash W. It means I am gonna select the word. If I'll replace this small word by capital word, then in that case only the not words will be selected. So that's the meaning. I'll share this link. This could be helpful for you. Okay. Plus means we don't know the length of the data. We don't know the length of the text. So that's why plus is used. If we will know that, okay, I wanted to only fetch the three-letter word, okay, then in that case you can write like this, curly bracket 3. This will mean that you are only targeting the three-letter words. Plus means the size of the word could be anything. Okay, clear? Now let's try to figure out the next part where we are focusing on the frequency distribution of the words. FDist. Frequency distribution of the words will be given by the word as a key and value will be their total count. Value will be their total count. Display your frequency distribution here. The more important than this will be that if we can convert them into a nice plot. So you can straight away use matplotlib package by using import matplotlib dot pyplot as plt dot figure, and take your figure size, fixed size equals to 18 cross 8, and then we can take here my f distribution dot plot, and we can also take here plt dot show part. So this is gonna be using this frequency distribution is a part of line plot, and that's how you see the line plot getting plotted here. The maximum frequency is for the word of, etc. The cleanliness is still incomplete here as we haven't implemented few of other important strategies. Okay, so we'll go one by one. First of all of you finish it till here and try to convert. Word cloud is only used when your total cleaning is done. Right now my cleaning is still not completed. Once the cleaning is completed, then only you can convert the word cloud, which will be targeting to the frequency only. Okay, that is also used to particularly display the frequency of the words. Okay, completed. It will appear automatically. You have to take. Can we display the labels in a slanted way to better distinguish them? For that, you have to target the label part and then you have to convert them into axes. I have tried it, but that will be not a great idea here. As you can see that when 90 degree is not fitting properly, then slanting will be also making it more difficult only. If you wanted to still do it, we have got something called as plt.xsticks, and with the help of that you can rotate the axes here. plt.xsticks, and here you can write like rotation equals to say 45 degree. So when you will write 45 degree, the angle will be automatically changed for the labels. Sorry, it has no effect on this. Because we are using the pandas data frame, just a second. This will be a little more tricky than. I have for this, for pandas plot, how does we change it? Just think about. Let me think about it. It should have worked plt.xtext. I don't know why it is not working. Rotation equals to 45 degree should have impacted this. Looks like that it is not working. How about this rot equals to 45? So taking that. Figure has been impacted, then why not this stick part? No impact. Okay, how about 90 degree? No, it is not getting changed here. Maybe there will be some other way of doing it, but as per my knowledge, PLT should have affected this. Looks like that these are all text data, so maybe it is not getting changed because of this frequency distribution part. It is this should be considered as above this. For the time being, just bear with this part only. Okay. And anyhow, 45 degrees or any other degree is not gonna be really helpful in this case. I don't think so. It will be making any good contribution. 90 degree is the best when your text size is large, which this one is adjusting automatically. Just pick the next part. The next part will be related to, okay, some more analysis. Sometimes there could be a great possibility in these type of sentences is that you have to convert the sentences into the lower case. So lower case is important, lower case paragraph, and your sentences are important. Lower case paragraph and sentences are important here that we must do. We do it with the help of lower function. Pick my paragraph, which is given by, first apply this paragraph dot lower. After this, apply the tokenizer to the updated tokenizer part, and then print your, no need for again importing the packages, print the new words. Print the new words. If there will be certain words which might be different, like Google in small and Google in capital will be considered as two different words. So it is always suggested that before you apply any strategy, you must convert your paragraph into the lowercase, and then you can convert them into tokenization. After doing this, if you will see the sentences, it has got many words which are useless. There are many words in this case which does not contribute, like and, like this is, and, that, on. These are good when you are, I'm talking about those words which are called as stop words. These are called as stop words. So the next part is removing stop words. Removing the stop words. NLTK.corpus, import stop words. Stop underscore words equals to list of stop words dot words English. Let's display the list of stop words here. There are other languages which are also supported by this. I'll talk about that as I'll progress ahead. But first of all, let's get the list of these stop words. Better print them using print function. So if your word present is present in this list of stop words, they will be eliminated. These are the list of the stop words for English sentence. What are the other languages which are supported then? If English is this, what are the other languages? So it can support most of the European languages, like French is there. Okay, Spanish is there. German language. So all these different languages are supported by this package, mostly English and European languages. Okay, don't expect to implement the Indian languages or Chinese languages. Those are not. No, no. Chinese and Hindi languages or any other related or any other Indian languages are not supported here. This takes only few European languages and most importantly English language. We got here all these details now. So in order to do this, we have to go through the loop and we have to filter the words. So filter underscore words is given by a list. Till here everybody is doing good, right? These are all simple things. For a word in my new words, for W in new words, if W is not in, if W is not in stop words, then you can just simple add it as your main for word list. So you can take a list here, filtered words, where we can append this word part, and that's how simple it is. Got here my filtered words. Got here my filtered words. Simply print them, and you will see the list of filtered words. And this is lot more cleaner data. This is lot more cleaner data. So I'm just sending you this part. After we are done with our stop words, filter the word, compare if this word is present in the stop words or not, and then print these filtered words. In the filtered words we are trying to target here, we are trying to check for word in the new words. What is new word here? New word will be available here. These are all my new words. So what you see here is these are all my list of the new words. And then what you can check here is that we can particularly compare that if this word is present in the list of the stop words or not. If it is not present in the stop words, that means these values, if it is present, they will be not considered and they will be eliminated. We are eliminating the stop words here. Just now I said if your word contains these list of the elements, we are not considering it. What is so complicated about this? We are just scanning each word and we are just comparing if word is not in the stop words, then we will consider it as or filtered word. Otherwise, that will be dropped or eliminated. So this was your before applying the stop words part where you saw that we had got unwanted elements like is and that on and it has been to. These are all part of the stop words which completes your sentences and but literally they don't have any meaning. So when you clean the sentences, there are two things you have to necessarily do. That is, one is converting all the words into the lowercase, and the second thing is that you have to scan all the values, all the text, and eliminate those unwanted words. So we have eliminated it by using just simple if condition. If your word is present in stop word, we will not append this into the filtered words. If the word is present in these stop words, that will be eliminated. If the word is not present in these stop words, that will be appended to my filtered word list. That's what happening here. So this is also a cleaning process of cleaning your text. This is also a part of cleaning a text. So after we have cleaned our data words here, this is how it will appear. Now in this case, you can see there are certain numbers as well. Repeated words will be definitely there. That is okay. That will tell you that what is the word frequency. Repeated words we don't have to target. That is part of your analysis part. That is not an error. Repeated or duplicate words are okay. That is not to be eliminated. Now the next thing that we have to do here is, all of you are finished till here? Everybody is completed? Everybody is completed till here? Please write yes in the chat window. Okay, after doing this, let us discuss the next part. After doing this, let us discuss the next part. Okay, so let's get started here. The next thing include lexicon normalization. You can also try to perform the analysis by one more thing. Let's say, okay, I'll just try to implement it. Import RE, and I'll be trying to apply here RE dot subtract, which will be targeting to all our words or integer value. You can pass here my text data, just like the way we have implemented here. Where was that regularization? Okay, yeah, here. I'll take here my filtered words, expected string or bytes like object. Okay, so maybe then it will target to take paragraph. This is a list of data, right? That's why. And this will target all those numbers type of data, and that will be eliminated. Okay, this is one thing. If you wanted to eliminate the the numbers from this is how you need to target. One more thing that we can do here is, in spite of writing this, we can write the loop. RE means regular expressions. We can try the similar type of thing here. In spite of filtered words here, we have got the list. For word in new words, if word is and target here, filtered word was already created, filtered words. For word in filtered words, if word, and in this case, what you can do is you can simply take this and you can apply this part, re.sub, and in spite of writing paragraph, you can write W. Now that will be okay, because now we will be passing a text data one by one. I hopefully this should be working here, which is working. And then what you can do is you can just try to write something like clean words, maybe clean words should be equals to the list and you can write here clean words dot filter, sorry, dot append, and you can write here this will be the return type. So let me take here my value, let's say some text, and let us pass here my text part. Now let's check our clean words if this has got all our numbers are gone or not. Here are your clean words. Now in this case you can see one thing as well, that some spaces are coming up, so that part you can also eliminate. So this is to clean and target only the, this is to clean your, this is an extra part, seventh part of cleaning, and that is regular expressions. Just like the way we have used at the top, regular expression to remove numbers or numerical values. You can use this type of example where you can simply eliminate the text and you will get the clean sentences. You'll get the clean sentences. Okay, here you go. Another important part, let me send you. RE stands for regular expression. Just now I discussed about the RE part. Regular expression. Backslash D include, this means that all the numbers we are targeting about all the numerical values. We are targeting here all the numerical values. Okay, so our text has been cleaned now. Now let's discuss the next part here. This is our mode of a cleaned text. Next is your lexical normalization. Next part is lexical normalization. The utility of lexical normalization is that it reduces the word to their base or root form, and it makes sure that whenever it applies a lexical normalization, it ensures that your word or text are linguistically correct lemmas. First method is lemmatization. Lemmatization that reduces words to their base root, to their base or root form. This is linguistically correct lemmas. Lemmatization from nltk.stem.wordnet import wordnet lemmatizer. Take here my lemmas which will be given by wordnet lemmatizer function. Okay, now let's pick your lem dot. Lam dot lematize. Okay, for example, loving. I have used word loving and I am writing here V. V stands for verb. So you pass here two things. One, word, comma. You will pass here either verb or a noun I mean, I'm sure about that you haven't forgotten this part of a speech thing. So what it does is it converts your word into a root word. If you will use here fit, feet, this will be converted into now. Suppose I'll write here feet here, and I'm writing here feet as a verb. But we all know this one that feet is not a verb, right? Feet is a noun. Its base root will be foot. So you have to particularly think about, see, most of the words that you will be scanning, those will be your verb part only. But there could be a chance that sometimes you will be having you have to scan just like the noun as well. So maybe you can scan all the words first by verb and store it, and then scan the same word by noun one by one, lematize it by using noun and lematize it also by verb, so that you will be having the base form ready. So in this case, you can think about here, this is your POS, part of speech tagging, part of speech tagging is there, that particularly converts that part of speech tagging. Here word is, let's take one by one. And let's see. So these are all your dummy examples. I will be implementing it to your some better examples here. Lam dot cacti, and we have got noun. Okay, markdown. Sorry. Here is your markdown. Got here my cacti, and we can write here noun part. Now cactus. Cacti is plural for cactus. So you can see that if you will write verb here, then it will remain cacti. And but if you will write and change it to noun, you will get the base root, which is noun. Similarly, we have got another word. Let's say buying. Buying is not the main word. If you will write noun, this as noun, it will not change. But as soon as you will write this as a verb, the buying will change itself to buy. So that's how these things work. Lam dot lematize. We convert our buying. We convert our buying as verb. Similarly, lam dot lematize, cactus will be changed to cacti, will be changed to cactus, and etc. There is another method following the same lexical normalization. One method is lemmatization. Lemmatization makes sure that your word will be converted to a linguistically correct form. Linguistically correct means the word which has been transformed will still have a meaning. Okay, but there is another thing. Sometimes you have to go through a process of stemming here. Stemming, this is process of, this is also doing the same thing just like the lemmatization, but the difference is stemming is a process of chopping off This process of chopping off affixes like S, ES, ING, etc. from words. This is process of chopping off the affixes like S, ES or ING, etc. from the words. Let's do the stemming here. From NLTK dot stem import porter stemmer. What this will do is it will simply target the last affixes value. If we have got S, ES, ING, these type of words in the end, it will be eliminating those values. Okay. So this is also one of the method that we use to remove the to convert your words into the root form. Porter stemmer. Let's see here, removing affixes like ing. We can write here p stem dot stem, and let's write here buying. So buying will be converted into buy. So for example, I had a word like buy. Buy has got, or maybe I'll be writing here buyings. Right, buyings is there. As I will write here this wrong type of word, and I'll apply the poster stemmer, you can see that all these affixes, which was INGS, is eliminated. Right, and we have got the root word as buy. This will not convert the word into their base form. Like for example, in this case, poster stemmer, I will be writing here. Okay, let me send you this example first. Now just watch. Now just watch here. Okay. Now what you're seeing in this case, the next thing that I'll try here, which will fail, is the plural of cactus, which was cacti, right? I'll write here cacti. The cacti will be unchanged. Okay? There is no support of noun or something like that is there here. So for few sentences, for few words, actually poster stemmer is also playing an important, is also good. Okay? Similarly, if you will write things like went here, that will remain unchanged by poster stemmer. Because for poster stemmer, if you will write here vents or venting, like venting is not a word, right? Then it will just target this affixes value. Okay, understood? That's the difference between your lemmatization and your stemming. If you will write here vents, this will be also converted into vent. For example, I can write here pants. That will get converted into pant. Okay, like trousers. So trousers will get converted into trouser part. Now let me send you this markdown part. So this will target here all these various affixes like INGS. Let me send you all this stemming part. Okay, so this will only target to chop off the affixes value. It is not like lemmatization, which will convert the word to its base form. Poster stemmer, got trousers here, and we will be taking up my P stem. Stem, got here my tools, and it will get 2. But what about if I'll target to convert this type of words with my lemmatization part? Now, I mean, you will understand why we need it. So suppose I have got buyings here, right? I'll write here buyings. Now buyings is a verb, correct? I'll write here verb. This will get converted into buy, no problem. But as soon as I'll convert this tools, tools is not a word. Two is, this has to be converted into two part. Okay, the two is a noun. So if you will write here n, then it will get converted into its base form. If you will write it as a verb, then it will remain as twos only. Okay, so that's how you have to, I mean, target your data before you write anything. These were some certain examples. Now we have to understand how to implement all this into our sentences here. Okay, the entire paragraph. Let's try to affect it. So if you will apply this to your entire paragraph, then this will get converted into their base form. And in order to implement it, again, you have to take the help of the for loop. Okay, like all my words are available in the filtered words, isn't it? So I'll target this filtered word. Let me show you. This is all my filtered words where all my words are available. Now I'm gonna use this lemmatization method to each and every word. So for W in filtered words, generally we do all this in one for loop. We don't have to split it, and just because you can understand it, that's why I'm splitting them into different for loops. Otherwise, they are all to come together to create one for loop, and then in the end you get a clean word. So for W in filtered words, and then what you do is here, you'll take your lemmatizer, and then you will be passing all your words. You will be passing all your words. Let's say all my words which are there, I wanted to scan it through verb. Okay. For the time being, I'm just lemmatizing it by using verb. I need to definitely store this result into certain variable, right? Maybe I can take an example of, let's say, words equals to this, and now I need to create a list where I can append all this value. So maybe I can take here clean underscore words equals to list, and now I will be targeting here cleaned words dot append and pass this word part, pass all these words. That's it. That's how these things work. Okay, fine. So let's see how does your clean words look like. I don't think so there will be any much large change here. Okay, so that's how the things are. If anything would have been having the, all these parts are there. You can see they're all gone and they've been converted into their base. So this is how you can implement it by using for loop. You can also target this word part. I mean, suppose you wanted to go through both the process, the noun as well as you wanted to convert that these words should also go to the verb as well as the noun part. Then in that case, you have to write it like this. And then you will have more cleaner words. First it will go through the verb and then it will go through the noun part. Okay, so that's the summary. This is how you can do it. You can use anything of this. I'm just gonna, I have used it for this part as this is just for one basic discussion where you can check if my words are cleaned or not. And that is done. And these are all done. So this is the last part where you can see that our word is created and these are your different process that a word needs to go through, a sentences needs to go through to prepare your final clean word. If you wanted to if you wanted to implement some frequency distributions once again, you can take your frequency distribution part, take your clean words, create your frequency distribution. That's your last section. There are definitely a lot of words has been eliminated and now we are left with just few important sentences and words. The frequency will be also changing itself if, like you can see, we had got first a majority of the frequency was there for all those stop words, which is now no more available to us. Stop words are gone and only the main sentences, the meaningful words are available to us. And this has also been converted into their base form. Stemming and stopping. There's a huge difference between stopping and stemming. Stopping, I'm sure that you are talking about a stopping means stop words. Stop words are totally different. This is an English word. Is, am, are. These type of words are called as stop words in terms of NLP. Whereas lexicon normalization is converting your word or sentences into their base form or root form. Showed you this beautiful examples here to convert like what is exactly the lemmatization means or stemming means. This is the process of converting the multiple form of the word into base form. They are not even closer which we are comparing. Stemming and stopping are two different things. Stop words are just words which needs to be filtered. So our words are ready now, and they are been converted. That's the end of your NLP basic. This is the end of your NLP basics part. Okay. What next we will be discussing is about your assignments. Okay, one more thing. We haven't talked about how does this NLP part works using your what you can say sklearn package. NLP package, NLTK package we have used, but we haven't used the your particularly the scikit-learn package. So NLP using sklearn package. Okay, scikit-learn package is important here. NLP using sklearn package. NLP using sklearn package. Okay, for example, we have the first package that I will be implementing here is count vectorizer from sklearn dot feature extraction what's going on, feature extraction dot text import count vectorizer to implement the NLP part using sklearn, we use count vectorizer. Can I have a quick done in the chat just to confirm that you all have completed till here successfully all these points that we discussed? So you can drop done in the chat for the confirmations. These are all English sentences, so I don't think so this is gonna be, this will be super easy for all of you. Okay, so NLP using sklearn package, that is done here, count vectorizer. Let's take our text data. Let us start with my vectorizer, which will be equals to count vectorizer function. Now let's tokenize. Let us tokenize here and build text vocabulary or text vocabs. So you will simply use this vectorizer dot fit, and you have to pass the text data. So I can simply take this paragraph that we have taken at the beginning, or maybe we can take sentences. Let's take sentences rather. This was your sentence tokenizer, right? So I am going to take the sentences and let's implement it into the count vectorizer, where we'll be having the sentences part. Let us implement this straight away. Take our tokenized text and pass your value here to fit. Once our fit part is done, just keep on watching the screen. I'll discuss it I'll share this at one go. Let us try to take this summary. Let us try to take the summary. In order to take the summary here, you will take the vectorizer dot vocabulary, and here is your vocabulary part. What you see here is a unique identity given to this text. What you see here is this is not word and frequency, but this is a ID which has been given to all your different sentences, and they have been converted into numbers. That's what the vectorizer is doing in this case, converting the words into vector, count vectorizer. First create your sentences into paragraph. So you can see that the utility of paragraph, where it could be used, and you will get here the summary of all the vocabulary here. Okay, how about if I wanted to finally convert them into vectors? So vectorize the entire document. What time? Entire document. Vectorizer dot transform, and you need to pass here the text data. You need to pass the text data. What is text data here? It's tokenized text. So first you fit it, and then you convert them. So this is created. You can see a very nice result is been given here, that it is converted them into a sparse matrix whose shape is 8 cross 124. After transformation, you'll get this result. Let us store it as a vector. What we did here is we converted the text data into a vector form. We converted this into a vector form. The markdown is simple, NLP using sklearn package. This is not important. What is important here is what this count vectorizer is doing. This is kind of a targeting the paragraphs or string data or sentences into a nice vectors form, into a number form. Okay, so what we did here is, because if you know clearly for machine learning, okay, especially for machine learning, these texts are useless. All these texts are good for analysis part, but as long as it comes to applying or implementing a machine learning algorithm, these will not be a really great thing, because you need numbers there. So one of the way is, what you can do is you can implement count vectorizer, and this will convert your entire paragraph or sentences into a form of vector matrix, which is called as sparse matrix as well. Okay. All right. So what you see here running this example, when you print your vocabulary part, you will see the sample and you will see the encoded document. What you see that there are, multiple words will be there in this case, and they have been given their IDs, or maybe the indexes. You can say that indexes here. Yes, NLTK is totally different from all these are totally different from each other. Now let's summarize here. Let us summarize here. First, let us print the vectorizer dot vocabulary. You'll get the words and their ID. You'll get here words and the ID. This is just an ID number given to the word. So the output from the vector is set of words and their unique IDs. This is not frequency. Remember that. So how many different varieties of words are there? That you can take it from the length, like length of what? Length of tokenized text will be there. So when you see that, what? Oh, sorry, it is taking sentences, right? Maybe we have to convert them into words to know that how many number of words are there. Basically, it has converted your sentences into words and it has also given the ID here, which was not done by the NLP part. In the NLP, this thing you have to do it only by the help of NLP, Skylon. Skylon, count vectorizer, it will convert, it will transform your sentences into words and then words will be given a unique ID and this is called as your vectorizer. Okay, clear? Vectorizer part is clear, everybody? Let's take here the length of this. Both the things are totally different. So you can see that there are total 124 different words will be there. So you'll see that there are unique ID has been given to all these different words. Few of them is starting from 0. So the last ID will be 123. 123. So this is also one of the method of whenever you, in the machine learning algorithm, count vectorizer is used, and if you just wanted to analyze the data, then NLP could be used. Okay, like suppose you wanted to implement in the text data spam or not spam or sentiment analysis. In those type of things, count vectorizer is used and not the other one around, not the NLTK part. I'm just sending it once again. Total number of words are 124. Every word looks like unique here. Anyway, vector shape, vector dot shape, 8 cross 124. These are all index positions, yes. These are all your index positions given to these words in the given to these words in your vector. These are all your index positions of index numbers, okay, which is also called as your position number for each word, okay. 8 denotes the number of sentences. 8 denotes number of sentences. Total number of sentence was 8. Shape will be 8 cross 124. Okay. So it is trying to create a matrix which is something like this. Let me take the help of the whiteboard here. Okay, I'll show you what is the meaning of this Y8 cross. There is no, this is nothing like what we want. Whatever is there, we have to accept that. This is not a number which is in our control. It's a process of pre-processing the textual data, which is never in our control. This will be in the control of the package that you are using. These are all predefined. So let's look at here the vector part, what exactly it is doing here. So for the time being, I'll give you two sentences to describe you here. Let's say we are learning NLP, or you can also say that natural language processing. This is your sentence number one. Sentence number two. Natural language processing uses NLTK, NLTK package or sklearn package, whatever you wanted to write. Okay. So let's write the sentences here. We This is your sentence one, and then we'll be having sentence two. Let us get started with things like we are learning natural language processing uses NLTK. Fine. So this will be full of paragraph. What is the shape of this? The shape will be 2 cross 1, 2, 3, 4, 5, 6, 7, 8. This is the total number of word, total number of text, and this is your total number of sentences. The shape is 2 cross 8. Similarly, in this case, we are having 8 cross 124. Similarly, in this case, we have got 8 cross 124. Got it? From where the shape is coming up. Now, these all will be filled with the values, which will be filled with numbers. If this particular word is present in the sentence 1, you will see 1, otherwise you will see 0. So in sentence word, these all words are present. We are learning natural language processing. This is 111. In the second sentence, natural language processing is there, so it will be 111 and 11. This is not present, so they will be filled with 0. This is not present, so they will be filled with 0. This type of matrix where most of the frequency will be actually 0. Okay, in this case, you can see most of them are 1, but in real world problem statement, there will be a lot of many words which will be there that will be not common among the document. Imagine this being your document 1 and this being your document 2. So what are these representing here? This is representing your frequency. frequency of words in document. Okay, got it? So just call this as, what type of matrix is this in front of you? It's called as a sparse matrix. Sparse matrix is a matrix where in which most of the data entries are zeros. Okay. If suppose in a sentence natural language processing is repeating 2 times, then this number will be also 2. So this is not that one hot encoding where every value will be 1 or 0. It could be 2, it could be 5, depending upon how many times that has been repeated in the sentences. But many of these will be 0, as if you will be having 100 such sentences, there will be many words which will be not even common among both. So the matrix that you finally create is called as a sparse matrix, and that has been presented here, 8 cross 124, and this is the matrix which has been available in a vector form to us. Next is, let us try to print the vector dot array. Vector dot to array, sorry. And this is what I was talking about. Clear? Now hopefully you understand that what these are, what is this vector means, and how does it look like. So this is your vector number 1, this is your vector number 2, this is your vector number 3, and this entire thing, this entire is a matrix. And what type of matrix is this? Sparse matrix. Why there are sparse matrix? Because most of the frequencies will be 0 in this case. Okay, so finally see your result of how does a vector look like for a particular data. This is the pre-processing that the sklearn uses to prepare your data here. So ultimately, this is the information that we require to implement any machine learning algorithm. Your data will be presented in this form, and this will be scanned for if it is a spam or not spam, etc., etc. Okay, so hopefully you have understood it, that how we transform the result and how does we get the values. 1 and 0 signifies the frequency. Remember this part, just now I discussed it. This is not only 1 and 0, but this could be 2 as well, this could be 3 as well. iPhone. This represents the frequency of the present. How many times natural language processing uses NLTK is present in sentence 2? 1 time. Similarly, in sentence 1, what is the frequencies of these? 1 time. If it will be present 3 times, you will see 3 there. If it will be present 5 times, you will see 5 there. In a certain sentence, wherever you see 0, it means your sentences are not present. These words are not present in your word. These particular words are not present. Wherever you see 1, that means that particular word is used 1 time. Wherever you see 2, that means the frequency of the word is 2 times in the sentence. These are all indicating the frequency of the words present in the sentence. 1 means 1 time, 0 means that word is not present, and 2 means 2 times, 3 means 3 times, and 0 means it is not present. Done? So shall we go for the break now? I think this is enough about all these explanations. What is the result? We converted the data into a vector. How does you will implement a text data into a machine learning algorithm? We cannot use the text data. So this is where this will be used. This is there used for your classification, sentiment analysis. In that, we actually use this sparse matrix. This matrix is called as a sparse matrix. So we have to always prepare your data into a sparse matrix before you implement this into any algorithm, which will be our next phase after this break. Okay, more talk after the break. Let us simply go to us. I'm starting the clock. Let's go for a 17-minute break, and when we'll come back, we'll discuss further more. The next part will be machine learning, which is will be implementing on over this NLTK part. convert, please show your presence in the chat part. So everybody, please show your presence in the chat. Welcome to post break session. Please show your presence in the chat, everybody. Just to continue our next part, please show your presence in the chat. Okay, so just now we have discussed about that how does we can convert a text data by the help of a count vectorizer into a nice sparse matrix, which will be frequency, which is a combination of all the frequencies of the words which are present in each sentences. So if that particular word is present, you will see one across it, or depending upon how many times that particular word is present. Okay, like for example, if any word is present two times, you will see two at that particular position. And if that particular word is not present in this document or the sentence, then you will see zero in front of it. Like we are learning is not present in the second statement. Okay, the second sentence does not have it, so they all are filled with zero. So just remember, this is what it is been representing here. These are all your frequencies of each word present in the sentences. Why does we need it? Why we have to actually take these type of data and actually convert them into your count vectorizer? So count vectorizer transforms your data into your text and into a particular text. Frequencies will be available to us. Now the next part that we can discuss here is let us try to implement the bag of words, and the next one is term frequency and inverse document frequency before we implement them into our final model. So how does we can do that? For that, I'll be taking up a simple spam detection example. I'll be taking up a SMS spam collection dataset, and that spam collection dataset I'll be using to particularly implement a spam detection classification by using natural language processing. So let me give you the data set from the available project list from the or chapter number 9. From this, I'll give you the spam collection data set. These are all your SMS data set. Okay, let me take the GitHub part. Give me a minute. Meanwhile, if anybody has got any doubt, hopefully you all have understood this vector part and all. If still having doubt, you can ask me. Let me upload meanwhile your dataset, and I'll be sharing you all. Excuse me. Okay, so here is my spam data set. You can see that this is all my available labels are there. Label is ham or spam. Label is ham or spam. Start with a file and new notebook. So take this URL, this is your data set, and here we'll be implementing the natural language processing to detect the spam. This is part of your assignment. Spam classification or spam detection. Okay, let's get started with first our libraries that we required. Import libraries, import pandas as PD, import a string from NLTK dot corpus, import stop words. All three important packages, libraries, first you have to import. Next, let us create our data frame. Let us create our data frame. In this case, the data is separated from each other by tab. In this example, you can see that the data is separated from each other by tab. These are all SMS, and we wanted to detect it whether it is a spam data or if it is a ham data. Let us take here data frame underscore spam collection. This is equals to pd dot read underscore csv. If you wanted to take the entire URL to read the data set, or you wanted to take the data from the given path, choice is yours. If you wanted to take it from the given path, you can directly write save as and take the data set. If you wanted to take it from the URL, you have to provide the URL. But this is not a simple data set to read, as first of all in this case you have to necessarily add the tab here. Tab is the delimiter. By default, comma was there, so you don't have to actually mention in that case. But here, yes, you have to definitely mention their names. Names are equals to two columns are there. One is given by response, and the second column detail is given by message. Second column is given by message. Response is there, message is there. So read your data set. First import your packages, then read your data set. After reading this data, names will be used to add the column names. Let's view the let us view the 5 records. Let us view the 5 records. Names are representing because we don't have a column name. That's why names are required. Separator is what why we use the backslash t, which means that the data is separated from each other by tab. So as these are tab delimiter, you will write here backslash t, and there is no column name here. Okay, let's do the head function. Let's do the head function, and this is how we can see our data. So response is your column number 1, and your message is also your data set. So this will be like your label, and this is your data. Now using this, we will be implementing it to our machine learning algorithm. Okay. Let's view the further more information using the describe method for our this given particular assignment. You can use the spam collection, and when it comes to viewing the more information about the data, we always tend to take describe function. We always try to take describe here. Describe is your 5572 responses. Then total number of unique values in this is 2. In this case, the unique value is 5169. The first value, the topmost frequency is for ham, and the topmost frequent value in the message is sorry, I'll call later. Total frequency is 4825, whereas in this case, the frequency for the top value is 30. Like ham is 4825 times, sorry, I'll call you later message is 30 times. That's how it is. This time you can see that the description of the data is talking only about the text data and their analysis. So the information here represents the total number of responses that are available to us. What are the unique values? In response, we have got 2 unique values. In this, most of the messages are unique, given by 5169. Sorry, I'll call you later is 30 times, whereas ham is 4825 times. Let's try to group them here. Let us view the responses using group by. So what you can do is you can simply take here group by and dot describe. Let us try to group it by response. Let us try to group it by response. Wait a minute. Group by response and dot describe. So ham is available here. Ham is 4825 times. Unique value is 4516. Top value, sorry, I'll call you later. Frequency is 30 times. Spam. Total count of the spam is 487. Out of this 487, 653 unique values are there. Please call our customer service representative. This is the most common spam mail. Please call our customer service representative. And what is the frequency for this? 4. So nice detailing here we are getting about the nice information we are getting about the messages. You will add a transpose, you will get much more better information. I'll suggest you to do the transpose here. T stands for transpose. Now let us take another information here, that is about the length of the messages. The next question is verify the length of the messages and also add this as a new column. DF spam collection. We take here length of the data. This will be given by, or maybe I'll replace it by message dot apply len function. So as you will apply len function to this message part, you will see the frequency, the length of the messages here. Store this into the length of the data set as a column, just to verify the message length, So we are having the data. Okay, now let's pick my df underscore spam collection. Let's pick my head. So let's verify the 5 messages with length. So this is your length of the data, length of the each messages, length of df column. No, column should be the column name. Yes, you can do that as well. But I think that will be for the entire data. I mean, this is not for individual value. If I'll take the len function, you'll get total length, no? That's the problem. You cannot use len function outside. You will get 5572. You are not going to get this type of data where you are getting length for each messages. Apply implements to each row, whereas len function will be for overall. Okay. Now create a function to get rid of all these stop words present in the messages. As we talked about earlier, we have to necessarily eliminate all our stop words which is present in our messages. And also we need to get rid of all the punctuations. To get rid of all the punctuations, we can use a string import package, and to get rid of all these stop words, we have to use the stop word here. Again, same logic, for loop, etc. we have to use. So let's get started. First def function name is message text process. Take your mess or message. Now check characters to see if there are punctuations. First part is check message or check characters. Check characters to see if there are punctuations. If there are punctuations, you can write here no underscore punctuation will be equals to char. For loop for char in message for character in messages if char not in string dot punctuation. So basically it is similar to what we did here. We'll consider only those characters, those are not in punctuations. Understood? This is similar to what we did exactly here. Using the for loop when we were taking up. Okay, we were eliminating those things. Like for stop words, we also written the same thing, that we have filtered all those words which are not present in the stop word. Similarly, here also we are taking all character one by one, individual character from this entire message. and we are iterating through each characters, and we are scanning it, and we are comparing if this is present, if any punctuations are there. If punctuations will be there, that will be eliminated. Like dot 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 is there, so those will be eliminated. Question mark is there, and any other commas, etc., semicolons, these all will be scanned. Now, this no punctuation will store all those words. Remember, this will be your word. This is not a sentence right now. This is no more a sentence. Okay? So we have to now form the sentence. We need to create the sentence again. So, no punctuation will be equals to join, no punctuation again. So created here my new punctuations, and now this is my sentence, and we will eliminate stop words which are present from the no punctuation. So this function will return. Maybe you can just first write about the sentences, or you can just create a return function. So let me first write it, then I'll put them in return type. Word for word in a no punctuation dot split. This will be splitting the word into chunks of word, and I will check here if word dot lower function, that means the data will be lowercase, and we'll check if not in stop words dot words English. This is the list of the information which will be given by, this will be returned from this particular function in a form of list. First, we will convert our punctuation part. We will split it into words, and then we will lowercase this word, and we'll compare if this word is present in the stop word or not. Only if they are not present in the stop word, that will be included as your final word, and that will be returned from this function as a message. Now let's verify it. Verify that your function is working. Data frame underscore spam collection. Take your message, and let us apply this function, which is message underscore text process. So this will be implemented. Okay, in spite of getting all the words, let us take only the head function. Okay, just display the first 5 rows. I'll terminate it. Okay, here are your first 5 words. Okay, now let me share it till which line I have given you, till collection head, correct? So here is your cleaning part. After cleaning the data, use the df spam collection and convert these words into a list of words. Here are your list of words that you see. These are all your list of the words that you see. Now we have got all these lists. You haven't called the function. What is the utility of apply? What is the utility of apply? Apply is used to implement the function to the column or to your data frame. So this is where I am implementing it. This is where I am implementing it. The function was created so that I could have implemented it directly, and this is a return. This was not created to call explicitly, but this was used for applying it to my column message. Okay, done. Fine. Now the next part that we have to implement is your just the things that we discussed here. The sklearn package. The utility of this count vectorizer was to convert all these textual data into a nice sparse matrix, which will be a matrix between your various sentences and the frequencies of the word which is present in it. So let us implement the count of vectorizer here, count vectorizer, and start your text processing using your vectorizer. Start your text processing with a vectorizer. Okay. I'm giving you time, all of you complete it till here, then I'll talk about the rest of the things. Once you are done till here, write drop done in the chat window. Done implemented. Please drop done in the chat window. Please drop done in the chat window. Okay, after you have completed all this, let us use the count vectorizer and convert the text into. Okay, so what is been created here is called as your bag of words using the count vectorizer. So call it as bag of words transformation. This will be given by count vectorizer. Analyzer will be equals to our function that we did here, and then will fit here, and while making fit, let's pass the entire data. Pass your entire data. Let us import it. Sorry, let us implement it. This is gonna take some time. This will take some time. As your number of words are more, So count vectorizer will take a lot of time here. We can expect as the data is large here. Okay. Now this bag of word is similar to what we have got here. The same thing is there. The only thing is the new thing is that we have to first go through the apply of message text process, and then you will fit. So first analyzer, then fit two process will be doing. Now you can see your data is ready. Use it as a vector. Use it as a vector here, the vocabulary part. Dot underscore dot vocabulary underscore. Let's take the length of the vocabulary. Let us take the length of the vocabulary here. Print the length of the bag of words. This particular thing is called as bag of word. What is created here? It has got a name called as bag of words. BOW. What a famous name in terms of analysis. This is going to take a little bit of time. So total number of words which is present in this is 11425. The total vocabulary in this case is 11245. Summary, sorry, let's not take all this value. Now let's implement the transformation. This part will be there. Vectorize the entire document here. So this is like take your bag of words and store the bag of words for the messages. Vectorize the entire bag of words using transform method. Those who haven't able to understand the previous part or having any doubt, through this you can easily able to understand. The resultant will be your, let's say, message underscore bag of words. But what we have here is a transformed vector data. I'll take this one, bag of words transformer or vectorizer, apply transformation and apply your spam message. Apply your spam message in order to finally get the vector outcome. Sorry, this will be matrix outcome, sorry. This is your matrix. Okay. Once we have got our message bag of words, we can use it. We can use it to check our further analysis. Like you can implement here array part to display the message data, and you'll see this type of result, which is okay here. Most of them, there will be a lot of data in this case. Rather than this, let's talk about the shape of this, which will be really large in this case. Array will be not presenting you anything, but yes, shape will be definitely giving us the detail. Total number of sentences were 5572 and the total number of words were 11425. That's the shape this indicates. That's the shape this is indicating. Okay. Now you have understood why we have done all these parts in the small sections. This is what the ultimate goal was. Now my data is converted into a nice numbers. As you can see, they are all converted into a simple matrix, which is called as sparse matrix. This is nothing but this will be your sparse matrix here. Once the data is converted into a sparse matrix, let us apply, in this case, term frequency and inverse term frequency for each bag of the word. So term frequency will be related to the frequency of the words present in the sentence. Okay, it is called as TF-IDF. I'll talk about the TF-IDF, but first of all, let's apply it as it takes a lot of time. TF-IDF, full form is term frequency and inverse document frequency. Term frequency and inverse inverse document frequency. TF IDF. Apply TF IDF transformer and fit the bag of words. Next transformation is get the TF IDF from sklearn dot feature extraction dot text import TF IDF transformer. This is what we need, TF IDF underscore transformer which will be given by TF IDF transformer function dot fit, and you pass here the message bag of words. Print the shape of the TF IDF. TF IDF. This is equals to TF IDF transformer dot transform. Then we pass here message bag of words, and that's it. Let's take the print here, and this is what the outcomes are. Message TF IDF. This is your inverse document frequency part. What you see here is your IDF, total number of words present in the document divided by total number of documents. That's what IDF is all about. TF IDF could be easily calculated by okay. So done, everybody. So document is your set of words and T is your word. When we say term, it means word here, and when we say D, it is nothing but it is your set of words. You can call it as a list of words. Okay. So there are two formulas that is working here for TF, term frequency. You can call it as TF. This will be given by TF, term and document. This is calculated by count of term in document. When I say document, it means it will be your bag of word, it will be your sentence, it will be your list of terms, and upon total number of words in your document. We are talking about this. Imagine that we have a sentence, right? In that sentence, there will be many words. So count of term in the document will be, TF, that is term frequency, is calculated. How many times that particular term is present in the document? Let's say I wanted to calculate here what is the TF for word natural. What will be that? Count of term in the document 1, and what is the total number of words in this document? How many words are present? 1, 2, 3, 4, 5, 6. 6 words are present. You will write 6. 1 by 6. This is called as term frequency. Next is your inverse document frequency. Inverse document frequency, or IDF, is given by, it measures the information or informativeness of the term. We calculate IDF. How it is it? 1, 2, 3, 4, 5, 6. Total 6 words are there. How it is it? Udayakaran, you have I think something is wrong today. You have been asking a lot of silly questions today. IDF, inverse document frequency. Inverse document frequency is calculated for term, which is given by N divided by DF. DF is your document frequency for that particular term. So this is your occurrence of this particular term in N documents. In N documents. Total number of document. Okay, all right. So that's how it is calculated. N upon DF. N is your count of the total corpus, that is your number of terms, and DF of T is your occurrence of term in the number of documents. That's how it is calculated. Now, because this will be a very large number, we take actually log of this. We take here a log of this. Number of term, we take a log of N upon TF. Number of total terms. Total number of term is what? 1, 2, 3, 4, 5, 6. Number of terms. Now, suppose I have taken a certain term here. Okay, let's say the total number of term is, how many of the values are there? 1, 2, 3, 4, 5, 6, 7, 8. But this will be again repeating. Just understand n will be your total number of terms. Okay, and then these will be those documents where this particular term is present. So total number of term is how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 is there. So you can just write here it as 11 upon how many documents are there in which natural term is present? 2. 2 documents are there. So 11 by 2. Okay, 1 plus df plus 1. So df 2 plus 1 makes it 3. This will be a large number. In this case, it still looks very small, but in real world, we will be having thousands of data here, and this will be few numbers. So that's the way. That's the way to actually make your data a little less to by taking log here. Just because we cannot have a lot of data, okay, and that's how we calculate all this value. Fine, take a log and calculate your IDF for the given term. Now that we have discussed about the term frequency and IDF, these are all your numbers that you are getting. Next part will be to implement this. Let us quickly implement it. That was all about your term frequency and inverse document frequency. Now let's print the total vocabulary attribute here. Sorry, that has been already printed. Take here my TF, IDF, message, applied, transform. Transform is also done. Let's take the shape. Let's take the shape of this. Sorry, what I'm writing. Shape. Yes, total number of documents where this particular term is present. DF is your total number of documents for the given term. You are looking for here, let's say, natural language processing, right? So you know how many documents that particular term is present. So occurrence of term in your end document. Okay, that's what I am trying to say. DF is your document frequency. But which document frequency? Those where this particular term is present. Ah, correct, correct. This should be 2. Just a second. Inverse document frequency we should have 1 because we could have a scenario of 0 as well. We can have a scenario, let me just verify. There has to be a 1 at the bottom. And the reason could be because here you will be having, there could be a scenario that you where your document, where there will be no such document where this term is present. So this is your Okay, see, 1 is added, I'll tell you why. In order to smooth down, see, there could be a scenario of divided by 0. That's why 1 is added. Your denominator could not be 0, right? Number of documents in, sorry, number of document that contains the term. This is okay here. Denominator will be 3 then. That is okay. No, it could be 0. What is this denominator part? Denominator is number of document that contains that particular term. So suppose we are looking for a particular specific term where this particular value is not there. So there could be a scenario where we can have a IDF part which could have a certain document that does not contain any of these terms. So that's why plus 1 is added. DF is your number of documents. But yes, this n will be not number of term, but it will be 2. Total number of documents. This has the mistake. This has to be number of document, not number of words, because number of word we have already taken here. Now that's your formula. Plus 1 is added because just to avoid division by 0. By 0 by 2. 2 is there, divisible by 3. Total number of document is 2, which will be fixed. And how many time, and my term was natural language processing, right? So I said how many documents natural word is present. So total number of documents there this natural word is present is 2. 2 plus 1 makes it 3. And why this plus 1 is added? This is 2 basically added here so that our model will not have a scenario of divisibility by 0. Log will be base 10. Okay. But your libraries, this could be base 10, I think, and in many libraries you will see that it is base E as well. So it will be natural language processing, sorry, natural log rather than being your base 10 log. So both in terms of mathematical equations, you will see somewhere base 10 is written, but your libraries, they uses base E. That is, it consider it as natural log. That's how you calculate your term frequency and your IDF part. So there is a correction here. This will be not number of words. This should be number of corpus or number of documents which are present, total number of documents. So in this case, what is the total number of documents? 5572. And out of 5572, how many documents are there where a specific term is present? And that's how for each term the IDF will be calculated. If that particular term is 0, okay, just to avoid that, 1 is added here in the formula. So we are done here. Let's implement the naive Bayes algorithm here. After this, let's apply the naive Bayes. Naive Bayes uses naive Bayes model. Final part is created where we will take this to detect your spam or not spam. Naive Bayes algorithm. Naive Bayes algorithm. So we have to choose here Naive Bayes model to detect spam or not spam from sklearn dot Naive Bayes import. Now in this case there are other versions as well. We will be using here multinomial Naive Bayes algorithm. Spam underscore detect underscore model. This is equals to multinomial Naive Bayes dot fit. We can write them in one line. In this case, you have to pass two things: the term frequency and inverse document frequency, and you will also take the spam collection response. You will take here your spam collection, that is your data. So pass your data, df, spam collection, and this will be full of all your response. This is your feature, this is your label. Feature and label X, Y. Our model is fitted. Now you can start, you are ready to make detection. That's it. That's how you choose your Naive Bayes algorithm to detect if it is a spam, and you fit the model, and as you can see here that we have fitted for our given X and Y. So what is our feature? Ultimately this term frequency and inverse document frequency will be given as a feature, and label will be your responses, which will be spam and not spam. In this case, you don't have to convert the label into the numerical form. That's one thing that you have to remember. Okay, let's try to check for any. Let's try to check the model here for their predictions. Check model for the predicted and expected value for the message. Okay, so expected response and your actual response. So this is about your final analysis. Pick my message, which will be given by. So you can take a message here from this spam collection. Just take any random message here, and let's see if my model is successfully able to predict it as or not. Let's say I'll take first message as your fourth index position. Remember, this message needs to go through the pre-processing first, which we did. Bag of words for message. This will be given by bag of words for bag of word transformer, sorry. No need to fit anything. Just like the way yesterday when I was taking the example, you have to simply transform it, like standard scalar, similar to that. You have to simply transform the message. You have to simply transform the message of index position 4. Sorry. Pass the message straight away. Message is a data this time. And then after implementing it, you have to get your TF, term frequency, and inverse document frequency. So TF, IDF transformer dot transform, and pass your bag of words for message. Got here my term frequency and inverse document frequency ready for this message, index position 4. Now you print the model predictions. For this, I'll take my spam detect model dot predict, and as a feature, you'll pass the term frequency and inverse document frequency. This will return you ham. This is your predicted value. What is our expected value? Expected value will be, also we can take it with the help of index position. Response index position will be 4. You can see that it is detected it as ham. You can see that you can easily detect it by ham. So this is your predicted value, model predicted value, and this is your actual response. Okay, that's how it works. Fine. So in order to check the model performances, once you have fitted it into your Naive Bayes algorithm, this type of things are solved by the Naive Bayes. It is simply using the probability part to detect which one is having the higher probability. So we are trying to predict here in terms of again probability part. We provide this term frequency and inverse document frequency as a feature, and we check probability for ham, and we also check probability for spam. The one which will be larger, that is how your Naive Bayes algorithm gives you the prediction. I'll repeat again. You have taken term frequency and inverse document frequency. So for every word or collection of word, we calculate the probability of your both the responses. That for this given TF-IDF, what will be the probability that it is a ham, and what will be the probability that it is a spam. And by comparing both of these, the one which will be larger, that becomes the criteria to choose the ham or spam predictions. You can choose different index positions here. Let's take a spam part as well from the data. Let's say index position number 2 is a spam. So let's pass here 2. Prediction is a spam, which is working good here, and this is also spam. So you can play around with this by various index positions, and with the help of this you can make predictions as well. And that's the end of your example. Why we apply TF-IDF method for response where? Definitely we have to imply it because we are treating this as our new data, and if this is my new data, I need to walk it through all the pre-processing that my text data has gone through. It is similar to like the way we have taken our previous algorithms where we implemented the pre-processing. So okay, so now let's try to detect here how could have been able to identify the accuracy. Where is the accuracy part here? What is this question? How could have been able to identify the accuracy of the model here if response field was not there? What? Where is the response here not available? There are two things here in the fit: term frequency and inverse document frequency, and here is the response. What question is this? Without the response, we will not able to detect. If response field will be not available, then why we will implement a supervised learning algorithm? This is a supervised learning problem statement. So why we will go into the hypothetical scenario that there is no response available. If there will be no response, use k-means clustering. And for that k-means clustering, you have to create again vectors. In that the responses will be different. Unsupervised learning is, by the way, not used for spam detection. For spam detection, we should have availability of a label. If you don't have the label, that means that is not used for the spam detection part. According to this data, we can only implement one type of thing, and that is a supervised learning algorithm. So response is important. Without response, we will not able to detect. Performance of the model, yes, definitely we can try. That is a legit question. We are having our model. Where is our model? Model is here. So, but we can check the score, right? Score. In order to check the score, we need two values in the same that we have fitted here. As we have not splitted the data here, which is okay. Let's take the score. It's coming out to be 97.936 accuracy. 97.93. It's coming out to be round up to 98% of accuracy. And if you wanted to create all those other analysis part that we discussed yesterday, then you can again use it. Name bias code, I'm sending it again. It is not working. Just like the way I predicted here, if a text is spam or not spam. So here also there was no label, right? This detected it as a spam, similar to that. Whether it comes to the spam emails or spam text, remember guys, there will be a certain label. First, your model will be predicting that, and then you will be changing your, you can see that your message and then according to your model trained, your responses, your predictions will be keep on coming up from the trained model part. Okay, so that's how these things work here. Now you implement the model and get the score done. I think the last part I have not sent, so the accuracy is quite efficient here, 97.98, almost 98%, which is a really good number. Okay, alright. Drop done in the chat if you are finished till here. I'll start with the last part of another chapter. This will be the last part. This is your another chapter, another lesson. And in the another lesson, we have to discuss here about okay. The next part that we are gonna start is my web scraping. Web scraping is particularly a technique to extract the information from the website. That's the information. Let's take a base first. Suppose we are having some HTML codes written. In that HTML code, there will be certain important responses, certain important information will be there. Okay, from a certain website. Like, I wanted to extract revenue. Okay, sorry, not revenue, ratings or review. We are having reviews here. We are having ratings here. Using the revenues and using the ratings, I can actually get the information about I can get the info about the data set from the given website, and the website part contains the HTML. So HTML info is taken and it particularly give us the reviews, and it also gives us the rating. These informations are coming up from the HTML, but how does we can convert them into a simple data frame? There comes the process of web scraping. There comes the process of web scraping where we can extract the reviews and ratings using our package called as, there are two packages which are important here, Scrappy or you can also use Beautiful Soup. Any one of these could be used to particularly scrap or extract the information from the websites. All you need is a URL. That URL will be providing us the HTML information or XML, HTML, HTML5, or your XML. So web scraping is a computer software technique of extracting the information from the website. This technique focuses on transformation of the unstructured HTML format of the data, which is available on the website, into a structured spreadsheet or database. Like here I have discussed the flow. We will be having HTML, we'll extract the information from this and we'll convert them into a nice data frame, or you can call it as a spreadsheet or a database. Particularly, it will be more of a readable format from an unstructured data. This is unstructured. So from this unstructured, you will be getting a tabular form of the data, more of a structured format. This process is called as web scraping. But what type of information we can scrap? Any type of information which is accessible to you. That means it should be locally accessible to you. Web scraping can be done in various languages including Google Documents, Python, PHP, R programming, Java, and so on. But mostly when it comes to web scraping, we are having a very important programming language which is called as Python, and this Python has got a lot of rich ecosystem. So using the Python, we can discuss here in terms of using this Python, we can simply discuss it by using web scraping, by using the web scraping techniques. For example, we have got Scrapy, from example the Scrapy part, and at the same time you can also use Beautiful Soup. Beautiful Soup. Okay, these are the techniques which Python programming uses to convert the data which is of HTML type, and that's where Python plays an important role. No, we are not collecting the information here. We are not collecting the information of data visualization. We are collecting the data, in fact, from the HTML. We are collecting the data from the websites. Like, suppose Amazon.com is there. From there, I wanted to extract the information. I wanted to extract the information from there. Correct? This can be done easily by the help of web scraping. This can be done by the help of the web scraping. Okay, every day you find yourself in a situation where you need to extract the data from it. Okay, this is just a plot that how it has been increasing day by day, why web scraping is important, and this plot is basically giving the information that it is exponentially increasing. The extraction is done here, and over the past years you can see that this process is increasing. Okay, that's what this chart is indicating. Okay, why web scraping? So you can have a simple example. Suppose you wanted to analyze the review of Apple iPhone. Which one is the latest? 13. You wanted to run review on this. We wanted to run the review over this. How does we can run the review over this part? If we don't have the information, what we have is these informations are available on Amazon Prime. Sorry, not Amazon. This is all available over Amazon.com. So here in this case, you can see that we are trying to, let's say, to launch some promo. Okay, let's take an example here. We wanted to analyze the reviews. So in order to analyze the reviews, what you will require? You require two things. You require the review, the text review. At the same time, what you require next is ratings. Without the presence of the rating, there is no significance of this text part. Rating will be the deciding factor for this particular text, and then we can particularly use our, again, natural language processing part in order to map our text with a given rating. There could be some negative rating, okay, like 0 to, let's say 0, 1, 2. This is all about negative ratings. And anything greater than 3 or above is a good rating, correct? So depending upon the various reviews which is available to us, you will get to see all your list of the data, all your information will be available. So this type of, to do this type of things in detail, you require web scraping. Okay, let's take some examples here. Software part we can take. Okay, I think this is targeting to Beautiful Soup, so let's keep it up to Beautiful Soup, which is our tool. It's an open source tool again, just like any other packages. And using this, using this library, we can detect the, we can target here to detect and